Good evening, children.
Good evening, ma'am.
Good evening. Yeah, we finished this one in the last class, right? Please check your notebook and let me know, children. We finished this right in the last class?
Yes, ma'am.
All right. So this is the next one. This was the last sum, right? We did it in the last class. The last one, right?
Yes, ma'am.
Yes, ma'am.
All right, children. So this is the next one. Again, the same heading. Check if the points are collinear or form a triangle. So see here. Here also, AB is when you work AB, 3 root 13 units. When you work BC, 5 by 2 root 13. When you work AC, 1 by 2 root 13. So 5 by 2 plus 1 by 2. What is 5 by 2 plus 1 by 2? It's 6 by 2. 6 by 2, which is 3. So 3 root 13. 3 root 13. So when you add BC and AC, when you add BC and AC, you get AB. You get AB. So since BC plus AC is equal to AB, the 3 points are collinear. They don't form a triangle. Yeah, please make, meaning you can take the help of the working here and work this similar to the earlier one. Find AB, find BC, find AC. If you want to show all the steps, you can just write square root of 3 into 3 into 13. Just 3 root 13 units. And here you can write it like this. You can write it like this, children. So that will be square root of 325 by 2. So 325, when you find the factors of 325, you will get 5 into 5 into 13 divided by 2, square root of 5 into 5 into 5 into 5 into 13 divided by 2. So this is nothing but 5 root 13, 5 root 13 by 2. Which is nothing but 5 by 2 root 13, which is nothing but 5 by 2, 5 by 2 root 13. And this one is, you can just write this as root 13 by 2, which is equal to 1 by 2 root 13. See, children, let me just read what I've written. I've just corrected it. I've written the answers directly. I just want to include a few steps. So see here, after root of 117, when you find the prime factors, you will get 3 into 3. The 117 is 3 into 3 into 13. So from 2 3s, 1 3 comes out. So 3 root 13. Then when you get root of 325 by 4, square root of 4 is 2. So you can see the denominator 2. Square root of 4 is 2. And square root of 325. You can see the square root in the numerator as it is. Square root of 325 by 2. Now, when you find the prime factors of 325, you will get 5 into 5 into 13. Square root of 5 into 5 into 13 by 2. So from 2 5s, 1 5 out. 5 root 13 by 2, which is nothing but 5 by 2 root 13. Then here, root 13, root of 13 by 4. So it will be root 13 by 2. 4, square root of 4 is 2. Root 13 by 2. Root 13 by 2 is nothing but half root 13 units. Yeah. And then you can follow, children. Yeah, please finish this quickly.
Ma'am, can you explain BC again, ma'am?
Is it over, children?
Yes, ma'am.
Okay. All right. Again, check if the following points are collinear or form a triangle. So I haven't, you don't see the steps here, but when you work this, maybe you can try it later. So when you work this, you will get AB is 5 units, BC is 5 units, and AC is 10 units. When you work this one, when you find AB using the distance formula, you will find AB is 5 units, BC is 5 units, and AC is 10 units. So again, AB plus BC is equal to AC. So that means the points A, B, and C are collinear. They don't form a triangle. So you can take down the question. Take down the question and leave some space. You can try it later. All right. Next one, check if the following points are collinear or form a triangle. So again, I have not, shown the complete working. Sometimes you will land with a situation like this, you get root 50. Okay, you get root 50. What is root 50? when you find root 50, what is root 50? It is root of, what is root 50? 2 into 5 into 5, 2 into 5 into 5. So root 50 is nothing but 5 root 2, 5 root 2. Okay. And what about BC, which is, let me write it neatly, 1 minute. Okay, so you find AB using the distance formula. You get it as root 50, which can be written as root of 2 into 5 into 5, which is nothing but 5 root 2 units, 5 root 2 units. Now BC is root 52. BC is root 52. And what is root 52? Square root of 13 fours are, so 2 into 2 into 13. 13 fours are. So it is 2 root 13. 2 root 13. And when you find AC is just root 2. Now see, what will you do? They're not like surds. See, earlier we got like surds. What do we mean by like surds? See, we got 3 root 13, 5 by 2 root 13, 1 by 2 root 13. We got like surds. So we were able to, add them and check if they're collinear or not. They were like surds in this question also. We got 3 by 5 root 61, 2 by 5 root 61, and root 61, all like surds. So it was possible to add the line segments. Now, this is where you get integers like 5, 5, and 10. So easy. 5 plus 5 is equal to 10. Now here, one is 5 root 2, the other is 2 root 13, and another is root 2. So it's not possible to add. 5 root 2 and root 2 are like surds. Okay, 6 root 2, but this is 2 root 13. How will you compare? How will you compare? So sometimes you have to find the decimal value like this. You'll have to find the decimal value. You should find the square root of these numbers by the long division method. You must find the square root of these numbers by the long division method. And what is the rule if it forms a triangle? What is the rule if it forms a triangle? The sum of any two sides will be greater than the third side. The sum of any two sides will be greater than the third side. So you will see that all these are true. All these are true. AB plus BC is greater than AC. The sum of any two sides will always be greater than the third side. So the points form a triangle. So the points form a triangle. I'll let you. So now further, if you're asked to, that's not here, but further, if you're asked to give a special name to the triangle, the only thing you can do is use the converse of Pythagoras theorem. Okay. If you're asked to give a special name to the triangle, you can use the converse of Pythagoras theorem. So what do you get? What is AB? What is AB square plus AC square? AB square plus AC square will be root 50, the whole square, plus root 2, the whole square. So that is 50 plus 2, 50 plus 2, 52 units. 52 units. And BC square, what is BC square? Root 52, the whole square, which is 52 units. So not 52 units. So this is area. When we say BC square, it's area. Just leave it as 52. So we find that AB square plus AC square is equal to BC square. So by the converse of Pythagoras theorem, ABC is a right angled triangle. And it's right angle at A because BC is the hypotenuse. BC is the hypotenuse. That means it's right angle at A. Let me explain again. So now to first show that it forms a triangle, you can see that the sum of any two line segments is not equal to the third one. AB plus BC is not equal to AC. When you add any two line segments, you don't get the third one. So clearly the points are not collinear because the sum of any two segments is not equal to the third one. So clearly the points are not collinear. So that means they have to form a triangle. They have to form a triangle. And you can check this. The sum, now what is AB plus BC? Sum 14, something like 14. It's greater than AC, 1.41. And what is BC plus AC? What is BC plus AC? 7 plus 1, 8. And it's greater than this one, 7. And what is AC plus AB? Something like 8, 7 plus 1, 8 is greater than BC. So the sum of any two sides is always greater than the third side. So the points form a triangle. And what kind of a triangle it forms? It forms a right angled triangle. How do you work that? How do you show it's a right angle triangle? Should work AB square plus AC square. AC square, which is root 50 the whole square plus root 2 the whole square. So it's 50 plus 2, which is 52. Then you must work BC square. BC square is equal to root 52 the whole square, which is 52. Now, since AB square plus AC square is equal to BC square, okay, since AB square plus AC square is equal to BC square, by the converse of Pythagoras theorem, by the converse of Pythagoras theorem, ABC is a right triangle, ABC is a right triangle, right angled at which is the hypotenuse BC. So right angled at A. BC is the hypotenuse. A is the right angle because BC, no? So the remaining vertex is A. So if BC is the hypotenuse, the right angle is at A. Right angle at A. Write this, children. Please write down this one. You know how to find AB, BC, and AC distance formula. So just write down what you see on the screen. Done, children? Okay.
Done, ma'am.
All right. All of you?
Yes, ma'am.
All right. So what I've written here is since AB square plus AC square is equal to BC square by the converse of Pythagoras theorem. PT is Pythagoras theorem. ABC is a right triangle, right angled at A. All right. Check if the following points form a quadrilateral. If yes, give a special name to the quadrilateral form. So now at this point, children, it's you have understood very clearly how to find the length of a line segment using the distance formula. You know how to find A, B, B, C, the length of the line segment A, B, B, C, C, D, AD, AC, and BD, the diagonals AC and BD. So I'll just show you the working and explain. You see here, this is the first one. This is the first one, children. was the first one. So we need to check if the points A, B, C, and D form a quadrilateral. Now we'll find we'll find all the line segments possible. So AB, BC, CD, AD. And then if it forms a quadrilateral, so we need to find the diagonals AC and BD. All right, so assuming it's a quadrilateral, we find the four sides AB, BC, CD, and AD. And then see like this. Okay, ABCD, right? ABCD. So we'll find AB, BC, CD, AD, and the diagonals AC and BD. And the diagonals AC and BD. So this is what is the finding, you know. We find that AB is root 10, BC root 5, CD root 10, AD root 5, and diagonals like this, 5 and root 5. Okay, so what do you observe? What do you observe? Why have we written rectangle? It's not a rectangle. Okay, now let me not comment. Work this, children. I don't know if I made any typing mistake. Also, I've written rectangle. Can't be a rectangle. It can only be with this values. It can only be a parallelogram. Children, please work and tell me. Take down the first one. Take down the first one. Because if it's a rectangle, I should get BD also has 5 units, or both should be AC and BD. Both should be root 5 or 5 units. Please work all these and tell me if my answers are correct. Or if you find AB, take down the first question, find AB, BC, CD, AD, AC, and BD quickly. Yeah.
Yes, ma'am.
All my values are correct. AB, BC, CD, AD, AC, BD.
Yes, ma'am.
Okay, so then it's a mistake. What I've written here is a mistake. Then ABCD is a parallelogram. Parallelogram. Because you can see that opposite sides are equal. Opposite sides are equal and diagonals are unequal. AB is 10, A, B, C, D. AB is root 10, BC is root 5, CD is root 10, AD is root 5. So clearly opposite sides, both the pairs of opposite sides are equal. So this is a property of a parallelogram. 9th standard quadrilaterals. Properties of a parallelogram. In the chapter quadrilaterals, properties of a parallelogram. In a parallelogram, both the pairs of opposite sides are equal. Conversely, in a quadrilateral, if both the pairs of opposite sides are equal, then the quadrilateral is a parallelogram. If both pairs of opposite sides are equal, then the quadrilateral is a parallelogram. So here you can see root 10, opposite sides, root 5. So it's a parallelogram. And the diagonals are unequal. AC is 5 units. Diagonals are unequal. This one is root 5 units. This one is root 5 units. Diagonals are unequal. If the diagonals are also equal, it's a rectangle. If opposite sides are equal and diagonals are also equal, then it's a rectangle. But opposite sides are equal. So it's a parallelogram. Diagonals are unequal. So it's only a parallelogram. It's not a rectangle. ABCD is a parallelogram, children. Understood?
Yes, ma'am.
Very good.
Yes, ma'am.
Very good. So why did we, is ABCD a quadrilateral? Yes. Yes, ABCD, that is the points A, B, C, and D form a quadrilateral. And the special name is parallelogram. Please write that correctly. After finding these, lengths, you must say the points A, B, C, D form a quadrilateral because both the pairs of opposite sides are equal. And it's a parallelogram. The special name is a parallelogram. Look at the next one, children. Look at the next one. So you also please work and let me know if my values are correct. I found AB, BC, CD, AD, like the earlier one, and also the diagonals, they're supposed to be diagonals AC and BD. All right. Now when you look at the working here, when you see this, 2 root 13, and root 13, it's very clear that BC plus AC. All right, it's very clear that BCC and BC plus AC is equal to AB. Root 13 plus root 13 is 2 root 13. So AC plus BC is 2 root 13 and AB is also 2 root 13. So AC plus BC is equal to AB. When does this happen? Only when 3 points are collinear. So which are the 3 collinear points? A, B, and C. AC plus BC. See here, AC plus BC is equal to AB. So the points are like this. The points are like this. AC is root 13. BC is also root 13. Okay, AC, BC, root 13. So AB is 2 root 13. So that means the points AC and B are collinear. But what is the definition of a quadrilateral? A quadrilateral is a figure formed by joining 4 points in a plane of which no 3 points are collinear. If 3 points are collinear, how can you get a quadrilateral? We have only 4 points. And if 3 of them are collinear and only 1 is away, how will you get a quadrilateral? You cannot get a quadrilateral. A quadrilateral is a figure formed by joining 4 points in a plane of which no 3 points are collinear. But here the points A, C, and B are collinear. How do we know that? The check AC plus BC is equal to AB. The sum of 2 segments is equal to the third one. And this is possible only when the 3 points are collinear. And you can see that diagram there. C in the middle, A and B in the ends. So since the points A, C, and B are collinear, the points A, B, C, and D do not form a quadrilateral. Do not form a quadrilateral. The first one in A, it is the first one is a quadrilateral because opposite sides are equal. Opposite sides are equal. And so it is a quadrilateral. And the special name is a parallelogram. The second one, you can see that collinearity check. So it's not a quadrilateral. It's not a quadrilateral at all. So how can you give a special name? It's not at all a quadrilateral. Am I clear, children?
Yes, ma'am.
All right.
Yes.
Yes, children. Yeah, please work this, children. It might look easy. Simply finding distance using distance formula. Maybe you're not able to get 2 root 13. So you might, maybe you're struggling with the calculation. So please work this one below the other. I just presented it like this. Don't work it like this. You write with the steps. AB is equal to square root of whatever x2 minus x1 the whole square plus Work, calculate and get the answer. Yeah, please work this. Show all the required calculations. I'm right here. Done, children? Please let me know.
Yes, ma'am.
Finished? Understood,
Yes, ma'am.
children? Yeah, so these are two different, yeah, they are different questions, but see the difference in the answers. So this is how you will have to conclude if it is a quadrilateral or not. Because that's a definition of a quadrilateral. What is a quadrilateral? It's a figure obtained by joining 4 points in a plane, of which no 3 points are collinear. So if 3 points are collinear, no quadrilateral is formed. So here the points A, C, and B are collinear. So no quadrilateral is formed. And the earlier one, if some of you feel root 5 plus root 5 is root 10, you're wrong. If you feel root 5 plus root 5 is root 10, no. Root 5 plus root 5 is 2 root 5. It's not root 10. Root 5 plus root 5 is 2 root 5. Root 5 plus root 5 is not root 10. All right. This is very important again. So why is the first one a parallelogram, children? Why is the first one a parallelogram?
Opposite sides are equal and diagonals are not equal.
Yeah, so it's a parallelogram. Correct. What if the diagonals were equal?
Rectangle.
Rectangle. Very good. Okay, so show that these points. Class, use the emoji. Raise your hand. Pranav, Ramnathan, Ananya, Nandini, Rajarajeshwari, Harini, Sneha, Murli, Shreyas, Kanishka, Priyanka, Hitesh, Netra, and Sashmin. Netra and Sashmin. All the children, very good. Netra, Sashmin is also there. Right, Sashmin, you're there, right?
Yes, ma'am.
Okay, good. Okay, so show that the points A, B, C, D taken in order are the vertices of a rectangle. Also find the area of the rectangle A, B, C, D. What's the formula to find the area of a rectangle? What is the formula to find the area of a rectangle?
L into B.
L into B. So tell me, what is that we have to find here? We need to find AB, then AB, then
BC.
BC,
AB, BC, CD, AD, AC, and BD.
AC, and BD. Okay. So supposing AB is 4, what should be BC to show that it's a rectangle? CD?
CD should be 4. Also be 4.
4. Yeah, if BC is 5, AD should also be 5. Why? Because opposite sides must be equal. Yeah. And what about the diagonals?
Diagonals should be equal.
Should be equal. Yes. So here you have to find the lengths of all the 4 sides, AB, BC, CD, and AD. Okay, here opposite sides must be equal. AB should be equal to CD and BC must be equal to AD. And also the diagonals, because you'll have to show that the points are the vertices of a rectangle. You will have to prove that these 4 points form a rectangle. So AB should be equal to CD, BC should be equal to AD. And also the diagonals. If the diagonals are not equal, it's a parallelogram. When the diagonals are equal, it's a rectangle. So you must show that AC is equal to BD. And to find the area of the rectangle, length into width. Yeah. So I have not worked it in detail, children. You can just go through this. We can go to the next one because nothing much in this. So see here, AB is 2 root 5, BC, CD, AD. You should express everything as a mixed surd, children, like this. 2 root 5, 4 root 5, like this. You should express as a mixed surd. Diagonals, 10 units. So opposite sides equal, diagonals equal. Therefore, it's a rectangle. Area of rectangle, L into B. L into B. See, ABCD is a rectangle. ABCD is a rectangle. AB into BC, length into breadth. AB into BC, length into breadth. AB into BC, AB into BC. How much is AB? 2 root 5. 2 root 5. And how much is BC? 4 root 5. 4 root 5. So 2 4s are 8. And root 5 into root 5 is 5. 8 5s are 40. 8 5s are 40. Yeah, so just take down whatever is in the slide, children. Write down. You don't have to calculate because you know how to find AB in detail. You know, just take down what you see on the slide quickly. Done, children? Okay. Yeah, sure.
Done, ma'am.
Very good. All of you?
Yes, ma'am.
Very good. Now tell me, children, how do you see? You'll have to show that it's not check if. It's show that the points A, B, C, D are the vertices of a square. How do we do this? We should find AB,
BC, CD,
BC, CD,
AD,
AD,
AC, BD.
AC, and BD. Now, what should be your findings to show that it's a square?
All sides are equal.
All
diagonals
sides
are
are equal.
All sides are equal and diagonals
Equal.
unequal or equal?
Equal.
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 Equal or unequal?
equal, ma'am.
What if they are unequal? What if the sides are equal and the diagonals are unequal? What will you call that figure? It is a rhombus. Rhombus, yes. When all the sides are equal and the diagonals are unequal, it's a rhombus. When all sides are equal and the diagonals are also equal, the diagonals will not be equal to the length of the side. It's not that all of them, it's not that all of them will be equal, meaning the diagonals and the sides. All the sides will be equal to say some 5 units. Diagonals will be equal to 5 root 2. 5 root 2. Supposing it's 5, diagonals will be 5 root 2. Diagonals will be equal. It will be equal to a different value. The sides and the diagonals will not be equal. So all the sides will be equal. That is some value. The two diagonals will also be equal. That will be a different value. But the two diagonals will have the same value. So that's what you'll have to do. You'll have to find all the 4 sides and the length of the diagonals. All sides equal, diagonals also equal. So it is a square. So in this case, you will find all the sides to be equal to 2 root 5 units and diagonals, both the diagonals equal to 2 root 10 units. So all sides are equal, diagonals are also equal, so it's a square. Is it understood, children? All of you? This is just using the distance formula, so we will not spend time working this. You can make a note of the question. Maybe if you're interested in trying it later, I'll show you both the questions. This you already wrote down. Yeah, this question, you can make a note of the question. All right. So again, show that you know what is the points. Sorry, yeah, sorry. Done?
Yes, ma'am.
So here we'll have to show that these points form a rhombus. And we also have to find its area. So what's the formula to find the area of a rhombus? What is the formula to find the area of a rhombus? What is the formula to find the area for rhombus? You don't want to say or you don't know?
Diagonal 1 and diagonal 2. Ma'am.
Diagonal 1 into no, Shreyas, D1
Diagonal
into
1
D2.
into diagonal 2. Ma'am.
D1 into D2, is it?
Yes.
Okay. No, I think Ram, I think it was Ram. So it is half D1, D2. Area of rhombus is equal to base into height. If you know the base, and height of the rhombus, base into height. Otherwise, the other formula is half product of diagonals. Area of rhombus is equal to base into height. Depending on the values given, whatever is known to you, you can use this formula, or area of rhombus is equal to half product of diagonals. Half product of diagonals. Meaning half D1, D2. Half into D1 into D2. Half into D1 into D2. Now tell me, children, to prove that it's a rhombus, what do you have to find?
The sides and the diagonals, the sides should be equal to each other. The diagonals can be unequal.
Can you just think again, Ananya? We have to show that it's a rhombus.
Yes, ma'am. All the sides should be equal to each other, and the diagonals.
Don't you think that is enough? Don't you think that is enough?
Ma'am, if the diagonals are equal, then it forms a square.
No, that's what. But a square is also a rhombus.
Oh, yes, ma'am.
So it is enough to find the sides. It's enough to find the sides. Simply find the sides AB, BC, CD, and AD. If all the sides are equal, it's a rhombus. They are not asking you to prove it's a square. When all the sides are equal, it's a rhombus. When all the sides are equal, it's a rhombus. A square is also a rhombus. Okay, if you want to be extra careful, see, this is enough. AB, find the sides, all the four sides are equal, it is a rhombus, that's enough. But here we have to also find the diagonals to find the area. Actually, to show that the points form a rhombus, you simply have to find the four sides. When the four sides will be equal. All the four sides will be equal. So it's a rhombus. Yeah, if you have to prove it's a rhombus and not a square, if you'll have to prove it's a rhombus and not a square, then you have to find the diagonals and show that the diagonals are unequal. Show that the diagonals are unequal. So since the sides are equal, but the diagonals are unequal, it is only a rhombus and not a square. So here we find the sides, and that is enough to show that it's a rhombus. All the sides are equal, so it's a rhombus. But why did we find the diagonals? To find the area. Half product of diagonal square units. So diagonals are AC and BD. 4 root 2, half into 4 root 2 into 6 root 2. So yeah, you know how to calculate. Yeah, make a note of this, children. Please take down this. You can maybe write it like this. AB is equal to root 26 units. BC is equal to root 26 units. CD is equal to root 26. And AD is also equal to root 26. So all the four are equal and hence it's a rhombus. First, make a note of it. And the area of a rhombus is equal to half product of diagonals. Half D1, D2. Done, children?
Yes, ma'am.
Okay. All of you? All right, remember the formula to find the area for rhombus, half D1, D2, half into D1 into D2. And to find the length, we use the distance formula. Yeah. If ABCD is a square with A and C given to you, find the coordinates of B and D. ABCD is a square is given to you. ABCD is a square is given to you. So there are 4 vertices, but you know only the address of 2 opposite vertices. You're given the address of only 2 opposite vertices, A and C. With the help of this, you need to find the coordinates of B and D. You see here? Very simple, but just that, you know, it's very elaborate. The working is a little tedious. You'll have to be very careful working this. So children, it's like this. You don't have to assume X and Y for both B and D. See, when you find the coordinates of B, you know, you'll get 2 sets. So if one of it is B, the other one is D. See, like when you find the coordinates of B, where is it? See here, B, yeah. See, when X is 9 by 2, Y is 1 by 2. And when X is minus 1 by 2, Y is 5 by 2. So for X and Y itself, you get 2 sets of values. For XY, you'll get 2 sets. So if one of it is B, the other one is D. If one of it is B, the other one is D. Because why we get 2 values for B, I'll tell you why. I'll tell you why we get 2 values for B. That's because B can be here or here, right? You can, how do you name the, the square? You can mark it A, B here, C and D. So if B is here, you get one set of values. Or you can also mark A, B, C, D like this. So B can also be here, correct? B can also be here. So you will get 2 addresses for B. You will get 2 addresses for B. B alone, you will get 2 addresses. See, how do you mark the vertices of a square? A, B, C, D like this. So that means B is here. So there's some address for B here. Or you can also mark it like A, B here, C and D. Then this B will have a different address. For this reason, you will get 2 answers for B. So if B is here, then D should be here, right? Or if B is here, then D should be here. So if one address is for B, the other address is for D. Am I clear, children? No, ma'am, is it? No, is it? Shall I repeat?
Yes.
Understood or not, children? Please respond.
Ma'am, can you repeat again?
Sure. Very good. Yes. Okay. Now, we are given the vertices of A and C. With the help of this information, we need to find the address of B and D. B and D. So that means what if you don't know B and D, what will you assume? Let B be X comma Y. Let D be A comma B, because you cannot say X comma Y again for D. So A comma B. So what I'm saying is you assume only B or D. Don't assume both. You assume the coordinates of only B or only D, any one. You have to find both B and D. But you assume X and Y only for B or only for D. Okay, now let's understand for B. It's the same. Even if you take D, the working is the same. Now I have taken B as X comma Y. But we have to find D also. No, I have not assumed anything for D. Only B I have taken X comma Y. Now, let's understand how to mark the vertices of a square. Now we can, how do you go about marking the vertices? You can say A here, B here, C here, D here. Or you can also mark like this, A, B, C, D. So when you work, children, for B itself, you will get 2 address. Why? Because B can be here or B can be here. So when you work, you should get all possible answers for B. See, in mathematics, when we work, we'll get all possible solutions. We always get all possible solutions. Okay, so it's not that there are 4 solutions. You get one solution, your friend gets a different solution, another friend gets a different solution. No, it's not like that. We get all the possible solutions. All of us can get all the possible solutions. So you can see B can be located here or marked here or here. Now, when you work, you should get both the address. When B is here, what is the address? Or when B is here, what is the address? So for B itself, you'll get 2 answers. For B, you'll get 2 answers. So if one address is for B, the other address will be for D. Or if one address is for B, this one is for B, then the other one will be for D. So since you'll get 2 answers for B, B and D are located opposite to each other, right? So for B, when you get 2 addresses, you will get the address for this point and this point. When you get those 2 answers, for B, you're getting the address of this point and this point. So if one address is B's, the other one has to be D's. Or if one address is B's, the other one has to be D's address. So I'm saying you don't have to assume the address of D separately. Since for B itself, you'll get 2 answers. One answer is for B, so the other one is for D. Okay, now I just assume that we all somewhat understood. Let's see the working and maybe we can again come back, because repeating the same thing, meaning repeating the information, I don't think will help in understanding. So let's do something else and we'll come back if we still don't understand. Okay, so I've just assumed the coordinates of B to be x, y. Now we need to frame some conditions. We need to frame, we know, there are so many properties of a square. So we need to use some property or properties, make some conditions and work the conditions. So what do we know about a square? So in a square, all sides are equal. We know that in a square, all sides are equal. Let's use that property. Let's make use of that property. See, we only know A, B, and C, children. So we are not talking about D. This portion is not in picture at all. This portion is not at all in picture. Because we have not assumed this address. This address we have not assumed. So you cannot find CD or you cannot find AD. You cannot find. We have not taken the address at all. So you cannot find AC, AD, CD. You cannot find. So it's like this portion is like in the dark area. This is not there at all. This is not there. It's there, but for working, we can't use this. So that means we have only A, B, and C. So now what condition can you create? AB is equal to BC. AB is equal to BC because in a square all sides are equal. So working that AB square is equal to BC square. So you know distance formula and all that. We get this equation. Just hold, I'll tell you why we have written this. So AB is equal to BC. See here, because that's the only thing you can say. AB is equal to BC. So AB square is equal to BC square. Work that and you get an equation in X and Y. I'll tell you about this one. Now, what's the other thing you can, say about this figure? So this is a right triangle. Because this is a right angle, it's a right triangle. So the other condition you can write is Pythagoras theorem. AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. That's the other thing you can write about this picture. All right, so this is another condition. So work. It's already AC square. So you will not get the square root symbol. It's already AC square. So that square root symbol will not be there. AB square, this will not be there. This will not be there because square. All right, children. So when you work this, you get an equation like this. You get an equation like this. So now actually you wouldn't have done this. How do we know that we have to do this? We would have stopped here. We would have called this one 1. And when you work ahead, you will get, that is with this condition, AB is equal to BC, you get this equation 1. And with this condition, Pythagoras theorem, you get this one 2. Now we look at 1 and 2. This one is in X and Y. So you thought when you work this, you will get this also in X and Y. The second one, when we work AC square is equal to AB square plus BC square, we were just waiting for another linear equation in X and Y. because that we know how to solve. But no, you don't get a linear equation x and y. So now how to proceed? You can proceed only by the substitution method. So what you will do, you'll go back to that one, equation 1, because that is only linear in style, because that's linear. So what you have to do to use the substitution method, you will have to write x in terms of y or y in terms of x. See, let's be very practical. How do you know that you have to work this? You really don't know. So when you start working, you'll stop, meaning when you work this condition, I'm repeating. When you work AB is equal to BC, you will stop here. You'll be so happy. Okay, I've got a linear equation x and y. So when I work this condition, I'll get another linear equation x and y. So you hope that and you work, but no, you're disappointed. So you find an equation like this x square y square xy. And you know very well that you cannot solve these two equations by the elimination method or the cross multiplication method, whatever you know. You have to solve this by the substitution method. So you come back to 1 because that is linear in style. Okay, so you come back to 1. What you do, you erase this. Okay, you erase this. You mark that 1, no? You had marked that as 1. You erase that. So you erase that. You erase that. And what you do, there's some little space below, so you squeeze there. You squeeze there and you write. There's some little gap, so you squeeze there and you write. You work this. So what is it? 10y is equal to, what is it? 23 minus 4x. 10y is equal to 23 minus 4x. So y is equal to 23 minus 4x by 10. Why should you do this? Because we have to solve by the substitution method. And now you call this one as 1. This one is 1. Otherwise, also you can mark that as 1, this one as 2, and 3 children. I'm just telling you so that you remember. So you erase that 1 and you work it further. 10y is equal to 23 minus 4x and y is equal to 23 minus 4x by, sorry. Very sorry, children. So continuing, so like this, we work 10y is equal to 23 minus 4x, y is equal to 23 minus 4x by 10. Now we apply this in the second equation. We substitute 1 and 2. So wherever there is y, we use 23 minus 4x by 10. You can also write x in terms of y. You know that. You can write x in terms of y or y in terms of x. Okay, I have written y in terms of x, and in the second equation, wherever there is y, we're going to replace that with 23 minus 4x by 10. And then I've worked here. You can see this. I think I've made some mistake. Mistake meaning this, I've forgotten some sign. Plus sign I've forgotten in the middle. I'll correct that. So this is what it is, children. So when you work, see that how it goes. So like this, and we finally get a quadratic equation. We solve and we get 2 values for x. We get 2 values for x. Okay, the working is very simple. Don't worry. Okay, so we get 2 values for x. Finally, you get a quadratic equation, and you split the middle term, and you get 2 values for x. Now, when you get 2 values for x, how do you find y? How do you find y? Y is equal to 23 minus 4x by 10. So you substitute that. You substitute both the x values there, one at a time, and you find the corresponding values of y. When x is 9 by 2, what is the value of y? When x is minus 1 by 2, what's the value of y? So like that, you get 2 address. You get one is 9 by 2. X comma y, no, what is b? B is given by x comma y. B is x comma y. Okay, so now we found x and y values. We found x and y. So we have 9 by 2. X is 9 by 2. B is 1 by 2. Oh, sorry. X is 9 by 2. Y is 1 by 2. And x is minus 1 by 2. Y is 5 by 2. This is what we get. So if this is B, then this is D. Or if this is B, this is D. Like this, we find the address of both the vertices B and D. Is it fine, children? Understood? We'll see the working. You'll be working this now in the class. So any difficulty you come across while solving, we'll discuss. Procedure is understood. Be very honest. Kanishka?
Yes, ma'am.
Yeah. Any questions, ma? You understand?
Yes, ma'am. No doubts.
Okay. Class others?
Yes, ma'am, understood.
Okay. Thank you for the responses. Yes, children, please start working. I told you this part of the triangle square is not useful. So AB is equal to BC is one condition and Pythagoras theorem is the other condition. Start working. Okay, let me clarify this part alone, children. This I've made a mistake while typing. See here. Here I've multiplied 3 with 23. Please look at this 3 with 23. So that will give you 69. This minus is the connecting sign. This minus will not come here, children. This minus is not here. It's a connecting sign in the middle, like here. Here. It's a connecting sign. This is plus. There's no sign here. That minus will come here. It's a connecting sign. 4x minus will come here. And then 3 into 23 is 69. And 3 into minus 4x is minus 12x. I have not multiplied the minus sign inside. That minus is outside here. I have multiplied only 3 with the terms inside the bracket. Only 3 I have multiplied. That connecting sign minus is there only outside. So that by mistake I put it in the numerator. It should come here. Minus. By mistake I put it here. Yeah. Minus 69 minus 12x by 10. Yeah. We'll finish this and wind up the session for today, children. Please work carefully. Do not blindly copy.
Completed, ma'am.
So this part, children, 23 minus 4x by 10 the whole square. So this is 23 minus 4x the whole square by 10 square, which is 100. See here, I have squared the numerator and squared the denominator. 10 square is 100. And here 3 into 23 is 69. And 3 into minus 4x is minus 12x. That minus sign outside here. That minus sign is outside here. By 10 minus 1 is equal to 0. Then common denominator 100. So it becomes 100x squared. And here you'll have to expand this one. A minus b the whole square is a square plus b square minus 2ab. A square plus b square minus 2ab. Then LCM. This is into 100. So minus 400x. This is into 10. All these numbers by 10 because the denominator is 10. You will have to multiply the numerator by 10. So this one into 10, 690. And this one into 10, 120x. But what is it? There's a minus outside. There is a minus outside here. I told you this minus is here. So when you take the LCM, minus 69 into 10, minus 690. There's minus here, children. So minus into minus plus. Plus. This minus into this minus sign. This minus sign will be applied to 69 and minus 12x. So it will be minus 690 and minus into minus plus 120x. Minus 100 is equal to 0. When you cross multiply, the denominator vanishes. When you cross multiply, it becomes 0. And then I've simplified the like terms. There are two x square terms. How many x terms? 1, 2, 3 x terms and 1, 2, 3 constants. All right, so we'll simplify the like terms. We'll simplify the like terms and that's how we get this. We get this x square term, x term and constant. Divided by 100 is equal to 0. On cross multiplying, 100 goes away, meaning 100 into 0 is 0. So then 29 is the HCF of these numbers. 29 is the HCF of these numbers. So dividing by 29 throughout. Now the question is, how do we know that 29 is the HCF? So have you all learned this chapter, real numbers? Real numbers? Oh yeah. How many of you have learned this chapter, real numbers?
Yes, ma'am.
All of you? Ranav, Ramnathan, Ananya, all of you, is it?
Yes.
Okay, then you must know how to find the HCF. How do you find the HCF? By the division method. So you take 116 and this is the easiest if you know that. Take 116 and 464. 464. Okay, 16, how many times? Is it 16, 116 into 4, right? Yes or no? 4 to carry over. 4, yeah. So 116, 4 times. 4 times is 464. So the remainder is 0. So the HCF of these two numbers is 116. The HCF of these two numbers is 116. Now take that 116 and the third number. How do you find the HCF of 3 numbers by the division method? Take up 2 numbers at a time. Divide, we got the HCF was 116. Now take that HCF and the third number, 261. 261. Take up 116 and 261. So will it be 2 times? No, because it'll be more than 300. So 1's a 116. 5 minus 1, 4 and 140. Oh my God, my division is wrong. 232. No, oh sorry. No, I'm bad at this. I'm no. 116 and 261. 2 times. 232. Nobody help me. When you subtract 9, 2. Is this correct, children? 29. Bring that 116 down. And 9. Is it 4, 5, 6? Tell me, no, somebody. 29 into 4. 29 into 4. 4, 6 for the 30. 4 9s are 36. 3, 11. Yes, 4 times. 116, 0. So 29 is the HCF. 29 is the HCF of the three numbers. So you'll have to find the HCF. See, how do you know? You'll have to divide by 29 throughout. So you should take up these three numbers, the numbers here in the equation, and find their HCF. And find their HCF using this division method. This is the easiest. This is the easiest. Don't do this method, what we have learned in our junior classes, 464. It might take time, you know, like this, finding HCF like this. It's time consuming. Don't do that. So like that, find the HCF of the numbers. It's 29. So divide by 29 throughout. And this is what you get. So this one by 29, divide this by 29, divide this one by 29, and this one also by 29. 0 by 29 is 0. Now split the middle term. The sum and product, you know that the sum is minus 16. The sum is minus 16 and the product is 4 into minus 9, minus 36. So split the middle term and find the two values for x. Then when x is this value, what is the corresponding y value? Substitute here. Y is equal to this one. Here you substitute the x value and find the corresponding y value. So we get 2 points, 9 by 2, 1 by 2 and minus 1 by 2, 5 by 2. So when B is 9 by 2, 1 by 2, D is minus 1 by 2, 5 by 2. And when B is this one, when this is B, this is D. Understood, children? Yes or no?
Yes.
All right. All right, children, since it's time, take a screenshot. Please finish it. Very important question. Please finish it. Take a picture. Very simple it is. You just have to know the conditions. We know that in a square, all sides are equal. And then Pythagoras theorem, because there's a right triangle. That's all. Just work with these conditions. Find the values of x and y. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you.
Thank you, ma'am.
Good night, children. Thank you.
Thank you, ma'am.
Thank you. Good night.